In the amazing world of Fallout, there's a wild concept called ghoulification. This crazy transformation happens when folks are exposed to super high levels of radiation, resulting in some serious genetic mutations. I was curious about how this all works, and whether there's any science to back up this mind-blowing change. So let's dive into it. Now, ghoulification isn't something that happens overnight. It's more of a slow and interesting journey. Different folks experience this change in unique ways, thanks to factors like their genetics and how much radiation they soaked up. While most people unfortunately end up facing the harsh consequences of radiation, a lucky few embrace this transformation. These individuals come out the other side with some gnarly abilities, even though they deal with some pretty intense physical changes. The impact of ghoulification in Fallout is pretty fascinating. Here's what's going on. Extended lifespan. Ghouls age way slower than regular folks, so they can stick around for a whole lot longer. Regeneration. They have some seriously cool healing powers that help them bounce back from injuries in no time. Radiation immunity. Ghouls can handle radiation like champs. What would normally be deadly to humans doesn't even faze them. Physical changes. The transformation does bring some changes. Think of necrosis and other skin issues that give them that distinct zombie look. But hey, it's not all fun and games. Ghouls often deal with societal discrimination and struggle with their sense of self because of how they look. So let's dive deeper and chat about the science behind these changes. So, what's the scoop on ghoulification? Radiation therapy is typically a go-to treatment for cancer, aiming to zap those pesky malignant cells while trying to keep the healthy ones intact. However, the link between radiation and healing isn't so black and white. Sometimes radiation can actually mess up the healing process in tissues that got hit. But there are specific situations where certain radiation types might help speed things up. Believe it or not, radiation can kickstart biological responses that aid in healing. This is especially true with low-dose radiation exposure, which leads to something called radiation hormesis. Basically, sometimes a small dose of something harmful, like radiation, can actually do a body good. Low doses can activate repair systems in our cells and tissues. Those low doses can get cellular pathways moving, enhancing DNA repair and cranking out growth factors and cytokines, which are key players in tissue regeneration. Plus, radiation can ramp up angiogenesis. That's the fancy term for creating new blood vessels, improving oxygen and nutrients delivery to wounded tissues, and helping them heal faster. Pretty cool stuff, right? Hormesis is such a fascinating concept. It's this amazing biological phenomenon where low doses of something that's usually harmful, like ionizing radiation, can actually have positive effects on our health. This idea shakes things up a bit by challenging the linear no-threshold model, suggesting that instead of just causing damage, low levels of radiation might actually get our bodies to kick into high gear and protect themselves. For example, these lower doses can ramp up DNA repair processes, encourage damaged cells to go through programmed cell death, apoptosis, and even supercharge our immune systems to better tackle cancer cells. And there's some pretty eye-opening research to back this up. A big study that looked at background radiation across the US found some solid evidence. that living in areas with higher natural background radiation, say over 180 mrem per year, can actually lead to a longer life. Folks in those high radiation zones were living about 2.5 years longer on average than those in areas with lower radiation levels, around 100 mrem per year. Plus, the same study noted a drop in cancer deaths for several common types of cancer among people exposed to more background radiation. How cool is that? Now let's dive into this intriguing idea of radiation immunity. You see, ionizing radiation has this complex dance with our immune system, influencing how it functions in some pretty interesting ways. When we talk about radiation immunity, we're referring to how our immune responses can shift from exposure to radiation, especially at those low doses. Let's break it down a bit. When we're hit by ionizing radiation, it's like a party for our immune cells. Various players like lymphocytes, T cells and B cells, macrophages, dendritic cells, and natural killer cells all get impacted. While high doses can shut these immune fighters down, yikes, low doses can actually lead to some encouraging shifts that ramp up certain immune functions. Low doses of radiation can kickstart our immune systems in ways like boosting our innate immunity. Those low doses can light a fire under our innate immune responses. Take macrophages and dendritic cells. They get better at presenting antigens after a little dose of radiation. This bump in antigen presentation means a stronger adaptive immune response. When radiation hits us, it can spark the release of cytokines, these essential little messengers that play a major role in shaping our immune and inflammatory responses. Some of those cytokines released after radiation exposure might even boost inflammation that helps the body spot and eliminate tumors. Isn't science wild? Did you know that being exposed to low doses of ionizing radiation over a long time can actually mess with your immune system? It's pretty interesting. While high doses tend to knock our immune response down right away, those chronic low doses might lead to some intriguing changes. If you're exposed for a long stretch, it could actually fine-tune the balance of immune cells in your body. This change might boost how well your body responds to pesky tumors or infections. Talk about a silver lining. On the flip side, though, there's some evidence suggesting that low-dose radiation might speed up the aging of our immune system, immune senescence. That's not so great, since it may make us more vulnerable to age-related illnesses or even cancers. Yikes. When it comes to radiation, especially the ionizing kind, it can really shake things up physically in humans. The way these changes show up really depends on how much radiation you're exposed to and for how long. To really get the lowdown, we have to look at how radiation interacts with our biological systems. So, here's the scoop. Ionizing radiation has enough energy to knock those tightly bound electrons loose from atoms, causing ionization. This can lead to damage in all sorts of cellular structures, including DNA, proteins, and cell membranes. The DNA is pretty much the primary target. When DNA takes a hit, a few things can happen. Luckily, our cells have some pretty nifty mechanisms for fixing that DNA damage. If it's a small boo-boo and the repair goes smoothly, the cell can bounce back to its normal self. How cool is that? But if the repair process doesn't quite get it right, we could end up with mutations in the DNA. Over time, these little mutations can build up, and that could eventually lead to cancer, which is not what we want. Now, if the damage is really severe, it could mean the end of the line for those cells. We call that apoptosis. A little cell death is manageable, but if a lot of cells kick the bucket, we could face some serious issues, like organ failure. Now let's talk about what happens when you get hit by high doses of radiation all at once. This is known as acute radiation syndrome, and it can bring on all sorts of symptoms, like nausea and vomiting, diarrhea, skin burns, and hair loss. These symptoms pop up because these high doses disrupt the way our cells function across various systems in the body. For example, skin cells are super active and divide quickly, making them extra sensitive to radiation. So they might get damaged pretty quickly, leading to burns or even hair loss. Not fun, right? So let's dive into the fascinating world of genetics and how it affects our survival, especially when it comes to radiation exposure. There are a few key players at work here. Some folks are naturally better at handling DNA damage thanks to super efficient DNA repair systems. Think about genes like BRCA1 or 2. They can really change the game when it comes to fighting off the nasty effects of radiation and reducing cancer risks. Have you ever heard of polymorphisms? These little genetic variations in genes tied to how our bodies deal with stress and program cell death can influence how well we bounce back from radiation hits. For instance, variations in genes like GSTP1 or TP53 might up or lower one's chance of developing cancer post-exposure. Pretty wild, right? Here's something cool. Some research suggests that certain populations might have inherited traits that give them an edge in resisting radiation effects. It's a hot topic that scientists are still exploring. Now, if we shift gears to the Fallout video game series and look at characters like Harold, a ghoul with a unique link to plants, it sparks an interesting conversation about radiation's effects on living organisms. Radiation can be a game changer. It messes with DNA, which can lead to all sorts of mutations over time, possibly resulting in many health problems. But let's clear the air on one thing. The idea that radiation could mix humans and plants into one organism? Yeah, that's not how science works. Sure, radiation can cause mutations in both plants and animals, including us humans. But these quirky changes usually stick to individual organisms and don't lead to some kind of crazy hybrid creature. Plants have their own special ways of reproducing, involving pollination and seed formation. For plants and animals to mix genetics, well, that would require some wildly complex processes that just don't exist in nature. So there you have it. The wild world of genetic factors and radiation, all tied up with a bow. While science fiction loves to explore ideas of mixing species due to things like radiation, real-life biology follows some pretty strict rules. For two different species, like humans and plants, to combine at a genetic level, they have to have compatible reproductive systems and genetic structures. Humans are mammals with specific ways of reproducing, while plants do it entirely differently. Chimeras can happen when cells from different embryos merge, but that doesn't work across totally different kingdoms like animals and plants. Considering what we know about genetics and radiation, the chances of plants and humans merging into one organism because of radiation are super low. Characters like Harold in the Fallout universe are just fictional creations meant to tell an engaging story, not examples of what could actually happen in the real world. So while Fallout dazzles us with its imaginative take on these transformations due to things like nuclear fallout, there's no scientific backing to suggest that any of this could happen in reality. Basically, the odds of radiation causing plants and humans to combine are extremely slim based on current science. The way a ghoul becomes feral isn't fully understood, but it seems to involve the brain deteriorating while the spinal cord keeps some ability to regenerate. This condition, called ferocious post-necrotic dystrophy, leads to the shrinking of higher brain functions, which ties into increased aggression and appetite. Factors like long periods of isolation or antisocial behavior among ghouls, along with heavy radiation exposure, might make this degeneration worse. Feral ghouls have no body heat and give off lethal levels of radiation, making them essentially dead, but somehow still alive, thanks to the intense radiation. This allows them to last for a long time, potentially even centuries, while looking emaciated from their decayed state. Once a ghoul goes feral, though, there's no coming back. Feral ghouls are driven entirely by survival instincts. They usually stick together and will attack any living thing that disturbs them with frenzied aggression. Their attacks lack any real coordination or strategy. When they feel threatened, they just swarm their target without any rank or hierarchy. These creatures often hide in dark places, like basements or underground areas, but they don't actually fear light, which is a common misconception. They might venture into open areas from time to time, but they generally prefer enclosed spaces where they can sneak up on their prey. Interestingly, feral ghouls can sometimes be seen using basic tools or weapons if they just turned feral, but because of their deteriorated nervous systems, they can't use these tools as effectively as non-feral ghouls. Recent updates in the Fallout franchise have added new explanations for why ghouls go feral. In the Fallout TV show, it's suggested that regularly using Radaway, a drug humans take to deal with radiation poisoning, is key to keeping a ghoul's mind sharp. If they don't use Radaway enough, they risk becoming feral. This new take differs from earlier game stories where it wasn't clear why some ghouls became feral while others did not. Before, it was hinted that psychological factors like isolation could make ghouls more likely to go feral, but that was only partially confirmed now. The shift from a sentient ghoul to a feral one involves complex biological changes, particularly affecting brain function due to radiation, and possibly made worse by isolation or lack of medical care, like Radaway. Understanding this transformation adds more depth to the story of ghouls in the Fallout universe and highlights the tough survival battle that these characters face. I hope you enjoyed today's video. Have a great day.